So I'd like to start my presentation just following Phyllis. I always like to start with a safety moment. And the topic I brought up, I'd like to bring up is in the power plant I worked at, we put our employees through a employee orientation. It's called Safestart. I don't know if you've ever heard it, but it's a nice little program that speaks about safety from a personal point of view that you use at work and at home. And so there's 4 states that can set you up for an accident. And these states are rushing on a job, frustration, fatigue, you're tired, complacency, you've done this job 100 times. So you find yourself in any one of those states, then you can end up doing something like your eyes aren't on your task. You hurt your hand because you weren't watching what you're doing. Your mind wasn't on your task because you were thinking about something other than what you were doing. Putting yourself in the line of fire, and the last thing is balance or traction. So not making sure your ladder is tied off like I did about 3 weeks ago, and so setting yourself up for an accident. And like I say, this was a nice little program. It let the people focus. It encouraged people to focus on what they were doing before they started the job. As a young operator, I worked in a high pressure, high temperature, high voltage plant. You purposely had to settle yourself down. You'd go to a 4 kV switch rack. You had to make sure that you were on the right unit before you racked out a 4,000 volt breaker. You had to make sure when you did the 240 kV switching, that was the breaker that had to be, the disconnects had to be opened on, because you didn't have any second chance. So a lot of those tasks put the fear of God in you. So you were scared and you were really paying attention. You know, a lot of things nowadays that we do is we do simple little things like go up on the ladder and we don't tie it off. Just silliness, you know. So anyways, that's my topic, and you can go online. They have a website. It's called Electrolab, and it's just called Safestart. So just have a look at it. It's something good for your employees. I'm not selling it or anything. It's just a good little course. Yes, so my topic today is magnetic filtration, and the examples I've picked are mostly power plant, power production related, because that's my background. And basically, I would like to speak on some of the pieces of equipment that I see great applications of this technology. And I've lived through the pain of it, through having outages and breakdowns. And so, coal-fired generating stations. I worked for TransAlta. I worked in all 3 major plants here in Alberta, Sundance, Keephills, and Wabamun. And those units were built in 1971, and they're going to be shutting them down starting this year. So they've served us well, but the equipment is getting old and basically needs a lot more attention than we've been able to give it. Magnetic filtration as it applies to power industry and coal-fired generating stations. Renewables, which are wind turbines, we're getting a lot more of those in the province now, and gas turbines. Some heavy equipment applications. Part of our assets included the Highvale mine, which is one of the largest mines in Canada for coal, 10.3 million tons a year we mine there. We burn about 91,000 liters of diesel fuel there too, so there are definitely applications there for, and then some of the applications in the oil and gas industry as you see it. Cooling tower gearboxes. We had a lot of failures when we first started bringing the cooling towers into the cogeneration business in Ontario, our first 2 plants. And basically, failure of the gearboxes, and a lot of it was due to contamination of the gears. And just simple. They just have a small, I don't know, like 30 or 40 micron screen in there, and obviously not enough to protect the engine or to protect the gearbox. And when these fail, typically they take the fan out, the whole works. There's a lot of damage, and you're looking at easily $500,000 to replace one of those. So we have applications where we can actually put magnetic filtration right into the gearbox. They're small, so you wouldn't have a full circulating system on them, but we could actually install a replaceable magnetic filter in there. And then there's the plugs, magnetic plugs that you can use in there, but I'd sooner go with the magnetic rod. We've gone out to a customer's place and we've spec'd them for his. I haven't installed them yet, but that's what's the matter. Pulverizers. Each 400 megawatt unit at Sundance has 5 of these coal mills. The smaller units have 6. They're a Raymond Bowl design. You have 3 journals, rollers that crush the coal. Each one of the larger mills will crush about 40 ton an hour. So the drive gear, there's a gear reduction box, a worm gear, and big drive gear down in the bottom. And it's fed by a forced lubrication system with just screen filtration in it, not even a fabric filter. So they're basically rock collectors. So I took a sample of oil from the gearbox, and you can see I just took sample oil and put the magnetic rod into the oil, and that's what I got. Since we can all see it, we all know it's greater than 40 microns, not the 17, 16, 13 standard that's, so bottom line, and other than that, if you see at the top, there's magnetic filtration of the hydraulic control oil. The rolls, the pressure on the rolls is controlled by hydraulic pressure. And there's a circulating unit down below, tank, with a basket filter in it. And these fail every once in a while too because of contamination. And again, perfect application for a little recirculating, you put a magnetic filter in there or even a scrubber. So that's where I've recommended for this application the Advantage 9000 magnetic filters on the returns to the hydraulic reservoir. So as the oil drains back down from the hydraulic units, it goes right through the filter.
Woody, how long would it take if one of those failed out in the field and you had to replace it?
Every time they failed on me, it took about 8 weeks to rebuild because the whole top has to come off the mill, and all the rolls, everything has to come out in order to get the gearbox out. The cost for the last job happened to me was $1.2 million.
Do you all have spare units, or do you have to be shut down the whole time?
No, so that I have a spare coal mill. But the problem is you take one mill out of service for 8 weeks, your whole maintenance program gets behind. And when I was trying to, like I'm retired, but when I was trying to budget for maintenance on this plant, I said, well, what we really should do is budget $85,000 a year for maintenance. And they said, well, why is that? And I said, because that's the insurance deductible. Because the work that we're doing is not paying for it, right? So, and again, as I said, as the units are getting older, we're getting more failures. In that plant, we're basically getting 1 failure a year.
I put a scrubber on a cart on a Philly gearbox on a pulverizer in a fire plant, and we ran, I think, for several weeks and didn't catch very much. But we kind of came off the very bottom of the thing. There was like a port,
Right in the sun. Yep.
and it went through the pump through our magnetic filtration back into the.
Yep.
Was that the wrong place to put my? Because I mean, we didn't pick up that much, and they'd been having some problems.
Yeah. I had the same problem. I had a portable kidney loop filtration system, and I'd roll that cart from one mill to the next mill. Yeah, and it wasn't effective. So
where does that 9,000 go into? Could you point out, if you don't mind, real quick?
So down under the mill, or under ours, was our oil pumps and the filtration units were down in the sump under the mill. So you'd pipe the 9,000 right in there. So that's for your year case lubrication. For the hydraulics, they're usually at ground level, and it's just a little sump tank. But as far as cost,
So you experienced the same thing with a kidney loop, right?
yeah, it wasn't effective with that, with the filters that
We're
we
having a
had.
problem, but that was not.
Yeah, it
okay,
wasn't.
I'll just talk to you later about.
Yeah, yeah,
I need to
okay.
figure out where that goes.
But that's where you'd put the filter down there, magnetic filter, and this is, you'd put it on the returns tank for the hydraulic unit. Easy. Another area of some grief, boiler feed water pumps. 10-stage Byron-Jackson 3000 PSI pumps, oil-cooled gland water, and also gland sealing water supply. Because of the contamination, we would lose our seals. So every time you shut the pump down, you had to isolate the suction from the aerator right away. Other than that, the water would leak out through the glands and into your oil, contaminate your oil sump, your oil every time you shut down. So what I recommended was, now you have condensate supplied, gland water supplied to your pump, and we just have a duplex strainer with just little basket strainers. Well, the amount of, being that that's condensate, it's coming off low temperature, low pressure part of your system, you get a lot of ferrous material, magnetite, spalding off. So these filters were always dirty and plugged, so it's an easy place to put a duplex filter. And again, each one of these feed pumps has a return dump to a tank. So it's easy enough to put a filter in your returns to your tank. The oil supply is driven off a shaft-driven pump, so you could supply it there, but this is probably the easiest place, is right in the returns to your tank. Steam turbine. Steam turbine, we have 4,000 or 8,000 gallon storage tank of oil. That oil, Terrestrial 32 supplies the complete turbine system. Lubrication, hydraulic control on your valves, your front pedestal, your overspeed bolts. Supplies the generator with oil, lubrication, and sealing. So this one oil supply is extremely important to keep clean. Unfortunately, we struggled with this all the time. We had instances where we had at least one shutdown a year that would be 4 or 5 days just to clean the contamination out of the front end pedestal. Like our overspeed bolts on a turbine were plugged. A lot of rust, and that's because of the water supply in there. Now, there's another reason for the damaged glands, and that's because when the water seal glands were replaced with steam glands, they didn't clean the system very good, and we had damage almost immediately. So we were always having water leakage problems into our oil. So you can put an oil filter, magnetic filter, in the returns right at the oil tank, right in where all your returns come from the turbine. Also, you need a good kidney loop filtration system for your clean and dirty oil system. When you transfer the oil for cleaning it, I would recommend the kidney loop filtration system. Also, if you're recommissioning after maintenance periods, you do an oil flush, you can buy the witches' hats. Now, we used to use those witches' hats just on originally commissioning and that, but they got the witches' hats. You can just slip them in and do a circulation and clean up any particles from there.
Woody, I'm going to bug you again. Your reservoir of oil that you're talking about, and it's significant in size from the sounds of it. When you have to replace that, what's the cost of draining it out, containing it in something, taking it somewhere?
Typically, we remove it during an outage and filter it and reuse it. But we're talking hundreds of thousands of dollars. I can't remember how much it is for oil, like 8,000 gallons, $3 a gallon. And I guess the other thing I'd really recommend is make sure you filter all your oil before you add it to anything with magnetic filtration. I live on a little hobby farm. I took a jug of Castrol 30 weight oil. I looked at it, it had been sitting around for a while, hadn't been used. I could see the magnetite sitting in there. And I'm going to add that to my engine. Like so, with all your applications, whether it's turbine, your mills, coal mills, have a small magnetic filter like a Y strainer that to filter all the oil that you add to that. Because that oil is dirtier than what the standards call for. You're putting oil in there that's got a particle rate of 20, I haven't got all the numbers, and you should be running gears down around 17. So you're adding dirty oil to start with. This is the slide that Roger provided me the information on. We are gaining a lot of Vestas wind turbines in Alberta. They're one of the largest manufacturers, and they've had a lot of failures on their gearboxes, and it's due to the coolant loop for the oil supply, and also just the gearboxes themselves. We haven't had much luck talking anybody in. There's one overseas, but the OEMs have played a big role in making sure that they don't have any added equipment on their equipment. So, I mean, again, ISO standard 1760 here. That's obviously not 1760. A lot of wear because of the gear problems they had themselves. A lot of ferrous on there, and plus the fouling if you're adding dirty oil all the time. So the oil is not being filtered properly. So I'd recommend you can have a Y strainer in there. I can't speak directly on the gearboxes because I haven't seen them physically myself, but we have solutions to these issues. And when those gearboxes fail, they are very expensive, very expensive.
Some companies put say a Paul oil filter that'll take out all the water droplets and all that other good stuff. Could you not, like on your turbine oil tank, could you not just put it through any secondary filtration system that you've got? You can just add it on to the end of that, I take it as well. Eh?
With our problem, when I was struggling with it, I had, I don't want to say it was a Paul, but it was a kidney loop media filters, and it removed some of the particles. But I had a lot of problems with water too. I had vacuum dehydrators on there, running 24 hours a day, and the kidney loop system will work, but there's large volumes of oil to treat there. So, and if it's portable, you're going to be taking it in a plant, 6 units. It's going to be going all the time. So, gas turbines. As you've heard, they're going to be shutting down all the coal-fired generation over the next 20 years in Alberta. So we're going to have to anchor our system somewhere. We can't do it with solar, and we can't do it with wind turbines. So we're going to be going to gas turbines. And the steam turbines were very forgiving as far as maintenance and operating conditions as compared to the new gas turbines. And I use as an example an aeroderivative turbine. We installed about 10 of these throughout the world, United States, Canada, Australia, this derivative. It's an aeroderivative. So I just wanted to go through it real quick. So you got a hydraulic starter on there, 2 gallons a minute, filtration 10 microns, nominal 25. Your geometry, your variable inlet guide, 1200 psi, 750 psi. Installed filtration, 40 microns, hydraulic system. And this is from the turbine manufacturer. Liquid fuel pressure, less than 20 microns. Oil pressure, 1,350 pounds. Installed filtration, 46 microns. And the filter will bypass at 35 psi. So you're not getting a lot of... So now I'm saying, because there's other rules here, and the rules say, they say you can't put restrictive or filtration on the discharge of your lubricating oil pump. So, but you could install magnetic filtration on your returns to your inlet to your tank, right? So it's not restrictive. And they do have magnets in there. They're called chip detectors. That tells you they catch anything from 500 to 100 or to 1,000 microns. So they basically just tell you that your engine's coming apart, and they catch the parts. It's not the problem. And I guess if you look in the manuals, all of the filtration requirements are as supplied by the customer. So turbine manufacturer doesn't take any responsibility. So I have to add, he tells me what filtration requirements are for the inlet to the turbine, and he tells me what, for any oil that goes into the turbine must be filtered to 3 microns. So that tells me right there, I have to pre-filter any oil I add to that turbine, because it sure isn't coming from the manufacturer at 3 microns. Lubricating oil supply. Lubricating inlet screen, it's got to be 30 microns. That's what they provide you on the machine. The lube oil discharge filter is 46 microns, and it bypasses at 4 psi. Oil must be filtered to a 3 micron prior to addition. That's what our turbine manufacturer demands. So my recommendation is you have to provide a lot better secondary filtration for your gas turbines. A lot of the failures we've had on the gas turbines have to do with seals, loss of seals, and that's particle. A lot of it's particle size. To add to that, now they've added sprint units and they've added NOx or water injection for NOx reduction. You got to make sure you filter that water supply, because when you're ingesting 500 cubic feet a second of air with water sprayed in there, anything that comes into the water or that's collected in the air is going right into your turbine. A lot of the, probably 20% of that air that's coming in is going directly to sealing, going through your air seals, going into your sump pressurization on your gas turbine. So any air comes through that filter from the outside. If it's not clean, you're pressurizing your lubricating oil sump with that dirt. So that's how you're ingesting more particulate matter. So NOx reduction, either steam or water. Steam because of the temperature. We have restrictions on magnetic filtration, but certainly RO water, you can filter that through magnetic filtration. Oil inlet glycol heating, another area where they use a lot of that instead of anti-icing. The smaller derivative units just use bled air off the 8-stage to heat the air coming up when you're in icing conditions. But glycol heating, huge problems, and we're looking right now at installing some magnetic filtration on that. And again, install magnetic scrubber filter on all new oil supplied to your system. Magnetic filtration will help reduce the varnish protection. If you saw the size of those, the micron size of those screens and strainers they have in there, because of the static electricity, the static charge that you're actually inducing in that oil, you're actually creating varnish problems. Now you can buy, they sell some very good varnish, anti-varnishing oil, but if you stop the problem, which is the static discharge of your oil, which is burning your oil, that'll help your varnish problems too.
So are you saying that it'll take away varnish, or
no, it'll protect it from
being created?
From being created, yeah.
Yeah, okay. So
on your air inlet filtration, so 5% greater than 10 microns in size. So if you, in Alberta, you see these forest fires we had the last few months, that's 2.5 minus particles in the air that we're worried about our lungs. Well, gas turbine is just a big set of lungs, you know, and I can guarantee you if you do a borescope on the compressors out here, you'll see that in those compressors. When we ran compressors at, or gas turbines at Toronto, filthy because of the VOCs and the highways, the rubber and that, just, you know, filthy all the time. Out in the middle of the desert, in Western Australia, you borescope those units and they're clean, perfectly clean. So industrial pollution and that really adds, and again, it doesn't take much, you know, power loss, if you know, 0.4% power loss and an increase of 0.2% with heat rate, that's just with 1 inch of water column drop. So, you know, you have to keep that compressor clean. And it takes you at least 16 hours to do an offline water wash. By the time you cool the engine down, wash, rinse, back on. So that's 16 hours. So if you can be doing that once a year instead of every month. But to be honest, we're just approaching this air filtration piece of it right now because it's so big. But there's definitely value for the customer there. So, and value for us, of course. Heavy equipment, everyone's talked about this. So, you know, in one of the cases I looked at, you had a 25% reduction in required oil changes, and your major rebuild duration or interval was reduced by 43%. That's huge. And that case study that Roger had, that was on a Crest coal hauler or mining hauler that already had 13,000 hours on it, and it eventually failed because of a glycol leak into the engine. So again, everybody's talked about this, but again, just the different applications on a D8 cat or D12 cat. If you can, you know, increase your oil change intervals from 250 to 500 hours, that's huge. Some of my notes on that engine, so that when they put the filtration on, the Advantage 9000, the P1 count went from 12 down to 1 in like weeks. And then it continued. And the particulate that was in there was ferrous and copper. So those are wear products, right? So, yeah, they increased their oil from 350 to 500 hours. And yeah, and again, it failed at $17,000 due to a leak. But engine rebuild on that was $350,000. And you probably already know this, but some of that hydraulic equipment already comes with ceramic filters in them. But I guess they have a tendency to break down. I don't know the details on it, but they're not as powerful as these magnets. This is a refinery inlet. You probably talked to that. So you've seen that sort of a loading, and this is condensate refinery. So all the diluent that comes from Montney and all the condensate, so that they use for blending the diluent before they send it down to the United States, to the refineries or to Edmonton. That condensate is not treated. It comes out of the gas plant. It's not treated. It's piped down to Edmonton and basically blended into the system, sent by Alliance pipelines or that back up to the, and they just keep recirculating that diluent through pipelines. And they pick up all kinds of magnetite. Just the whole gas plants, and they're full of magnetite. I remember as a kid working in a gas plant, anytime you had an upset in the gas plant, what you use to strip the hydrogen sulfide out of the gas is called sulfonol. It was a shell product. If you had a shakeup in your system, all your screens were plugged. That's all you did is change screens, and all it was just black magnetite. So any shakeup, and that material is always circulating through the whole system until we have a shakeup in the plant and you clean some out of your strainers. But I didn't know what it was. It was just dirty and stinky. And so great opportunities in the condensate business here, since they produce and transport about 500,000 barrels of condensate a day within Alberta.
So that's 32 rods in the single housing?
Yes.
Yeah, 32 rods here, yeah. This is big. This is like 7 feet or something. This is a big
2-inch
unit.
OD, 5-foot long rods.
Yeah.
One thing that hasn't come up too much today is the concept of warranty. Because with OEMs, there's this whole, I just smile at Richie. You know, there is this presentation from OEMs that, you know, you need to maintain your warranty with us, so you need to maintain the maintenance schedule that we present to you. And, you know, this gets brought back to us a lot of times that they don't want to change out from an OEM product because they don't want to miss out on their warranty.
First of all, aftermarket equipment like this does not affect your warranty. There's been a legislation passed in the United States, Magnuson, whatever. They can't step in there and threaten you with that unless they want to give you free filters. You use our filters and we'll give them to you. We'll give them to you free. You use them. Then they might have a leg to stand on. As far as warranty, we had a brand new turbine come in. It was a new design. And an insurance claim, insurance agent always told me once, he said, the OEMs manufacture them and the insurance companies pay for them. And that's what happened. We had a brand new design on a gas turbine where they changed the design of the high pressure compressor. 2 weeks in, 7th stage blade on the high pressure compressor failed. You know what the warranty was? They will replace that blade. It cord cobbed the whole unit. So I'll take my chances, you know. So, and I guess I'll give you another little bit of an experience. If you're installing this stuff, you as an owner have to take good responsibility for it and not leave it to those people. They're good people, but you are the owner. That's your equipment. I got 5 turbines delivered in the United States. I said to my commissioning manager before we started them, I said, you will borescope every one of those units before they turn over. Because once you turned it over, well, when did that happen, right? This funny thing happened. When we did a borescope, all of those compressors had been machined. And no, it had been machined and brushed up for some reason. So we went back to the OEM, who I won't mention, and they just didn't know what happened, but they did an investigation. Found out when they punched the silencing, you know, the air silencer in the inlet, a lot of the coupons, the little coupons, went into the engine. And then they ran the engine. And then they had to clean the engine, then they had to repair it. But they never said anything to us about it. So I had everything on film, just in case I had a failure, because that was on them. So, you know, don't get too hung up on a warranty. That's, you know, take responsibility yourself. And
You said that aftermarket products, said the warranty, you don't have to worry about them. I mean, they can't void your warranty for using.
no, if they've told you, yes, there's a lot. Now, if you've done something that's against their recommendation, as far as like, if you put a restrictive filter downstream on a supply line, that they say, no, you don't do that, because we won't do that. But if I put a filter on the returns tank where there is no restriction, as long as they follow the rules, they can't come back and say, well, that was in the tank. No, if I put a restrictive filtration in and there's a restriction in the supply to the turbine, yeah, they would probably.
The magnetic filtration doesn't restrict any flow at all.
No.
Not even when it's filled.
Exactly. So it just, I guess, it's how, when you get into these packages, a lot of it is where is it easiest to install that equipment too. You know, it's a lot of it's seal welded, and there's just a, you know, and it's all stainless. So sometimes it's simplicity on where to install it for the customer. That's all I was recommending, is it's easiest to do it here. And if you make sure all the oil in that tank is clean as a whistle. You shouldn't be getting a lot of ingress unless you're getting ingress from your air filtration system, which in an industrial area like here, your compressor is going to get a lot of small particles in there. So,
you talk about, I didn't catch your whole story about the 3 micron requirement for one of them. Was it a gas turbine?
Yeah.
Could you tell that story again?
but just the manufacturer requires that the oil must be filtered to 3 microns before you add it to the system. Yeah, well, they're just basically screens. They're barely filters. Yeah, and the cleanliness standard when you're commissioning those units is not at that level. It's class 8. Class 7 or class 8, which is much dirtier than what they're calling for.
Could it back you up to the RO system cleaning?
Yep.
Or water cleaning? What do you expect to get out of RO systems on a magnetic filter?
You'll get magnetite out of there, and you'll get some non-ferrous, and you can get some slippage. So it depends on what kind of RO system you have.
It's all membrane and it's all on stainless steel.
It's membrane, so yep. So an RO, you'll have sodium zeolite, and then you'll have an RO, 2-pass RO.
Right.
And now, what are you storing the water in?
Fiberglass.
Yeah. So as long as it's not touching any metal, you might be all right.
Okay, but as soon as you store it in a
Anything
steel tank, then away you go again.
into anything metallic, you're gonna pick up some of the micron
Yeah.
stuff.
Okay.
And RO is not ultra fine. It's not ultra filtration. You're still getting TDS going through there.
Right.
So you're still
And the magnetic filtration will capture that?
yeah.
Okay.
A story. We had a gas turbine manufacturer from Southeast Asia. They're using untreated water for injecting into the coolers. Like I think they had curtain type coolers. Anyways, the PT pickup, the probe is about like my finger. That's $15,000, and it was like a tea kettle. It just plugged up like your tea kettle, and I guess all of the cooling. So all of those cooling vanes, you've seen the holes on the turbines from the seals. I mean, they were completely plugged, and they wanted to know if they could acid clean. I told them just take it to get whatever scrap metal you can for it, because it's impossible to get anything like that. But that's how fast you can ruin one of these gas turbines so fast. Maintenance costs. Overhaul on a GT26 gas turbine, hot pass, major overhaul, $27 million. That's 10 years ago. $27 million. We used to get the blades, come out to the plant, and they're in boxes like this, and there's 72 blades on the one rotor. And we just go 1 Mercedes, 2 Mercedes, you know. So that's how expensive they are. So that you really, and so you got your CT inspection, which is nozzles and just basically a minor at about $24,000. At $48,000, that's a complete rebuild. And on one of these small gas turbines, a new engine's about $7 million now. Just take the engine out, put a new engine, about $7 million.
About $5 million 2 years ago for a solar turbine.
Yeah. Those are nice little units. Yeah, but what I'm talking about is aeroderivative, and it's about $7 million US. Okay. Thank you for your time, gentlemen.